Right, so for our other two types of reactions, they are again similar to each other, less related to our synthesis and decomposition reactions. Our first type of reaction is called a single replacement reaction. Basically replacing an element within a compound with a different element. So one element's kind of replaced from a compound. A new element is added as a reactant, and then it takes over that place. So there's basically just a kind of spot in our reaction where two compounds are switched around. It's got a couple of examples here. So if you imagine A is a metal, B is a metal, B is a metal by itself, AX is an ionic compound. So metal B is added to compound AX, and the A and the B switch places. So A would exist as a metal afterwards, and B would exist as an ionic compound with X. It can also occur with two nonmetals and a ionic compound. So you have nonmetal X, nonmetal Y, and you have metal A. So again, Y exists by itself before the reaction. It's added as a reactant, and then exists as a compound as a product. It's got one example of a metal replacement. So you can take aluminum foil and you can add it to copper 2 chloride. Have seen copper 2 chloride in the lab. It's a very bright bluish green solution. We used it as a decomposition reaction. In this case, we are doing a single replacement. So the aluminum foil reacts with copper 2 chloride. The aluminum basically takes the spot of the copper in the copper 2 chloride. So aluminum reacts with the chlorine, forms a compound with the chlorine, you end up with an aluminum chloride. And then the copper will kind of take the place of what the aluminum used to be. So you're starting out with metal aluminum, and you'll finish with metal solid copper. You can also perform this reaction where a nonmetal is being replaced. So you can take fluorine gas, again fluorine is F2, and you can kind of bubble it through a solution of sodium iodide. It's kind of like carbonation. Instead of carbonating with CO2, carbonating with fluorine. This reaction will produce sodium fluoride dissolved in solution and some liquid iodine. So again, we've got our fluorine reacting with sodium iodide, producing iodine just by itself and a sodium fluoride. We did perform a single replacement reaction in your lab where we were looking at how to produce different gases. Took magnesium metal and hydrochloric acid, performed a reaction, saw some bubbles. Those bubbles were bubbles of hydrogen. In that reaction, the magnesium took the place of the hydrogen in the hydrogen chloride, and it produced hydrogen gas and magnesium chloride. Got just another example of a single replacement reaction. Another analogy. Just got a couple, and then eventually just kind of one person decides to switch for another partner and end up with a single person again, but we've kept a couple throughout. So again, we've got another example of a single replacement reaction. This one's not in your notes. Look at zinc and a copper 2 sulfate. So what will this produce? So let's look at those formulas first. We've got zinc, it's going to be a metal, and we have a copper 2 sulfate. It's probably going to be dissolved in water. So we've got one ionic compound and one metal. So those metals are probably going to switch places. So the zinc is going to take place of the copper. Copper is going to take the place of the zinc. Metals are just going to switch spots in that formula. So when we can predict our final formulas, zinc will take the place of copper. Copper will be by itself. So we start out with zinc as a solid, copper 2 sulfates dissolved in liquid, and we'll finish it up with some solid copper and some zinc sulfate. Just kind of take note of those different states of matter. So we have zinc as a solid, we have the copper 2 sulfates as an aqueous solution. At the end of our reaction, we're still going to have a solid, we're still going to have an aqueous solution, but those products will be different. When we react this, copper is going to be a solid, it's going to form a precipitate. Did see precipitates in that lab with the well plates, produced some chemical reactions, and you saw flakes of metal falling out of the solutions. Basically, these metals will take the states of the metal that they're switching with. Another thing is that the metal that is coming out of the solution will kind of lose its electric charge. So it's taking back a couple of electrons from the zinc. When this happens, the copper will become a solid. Zinc is going to then take on an electric charge. It's given those electrons to the copper. And then the zinc will be dissolved in water instead of the copper. Last step is to balance. However, this looks like it's already a balanced reaction. Got a few more practice problems. Take a few minutes, try and go through these. I'll have the meeting open so you can ask any questions. Our last big type of chemical reaction is a double replacement reaction. Very similar to a single replacement, except this time we'll be dealing with two ionic compounds. So with our compounds, it's basically a swap of elements to form two new compounds. So two compounds will react together, and the elements are going to switch places. When this happens, one of those solutions will typically form a precipitate, and another will stay dissolved in water. So one of those two products cannot stay dissolved in water. It's going to turn into a solid when it's formed that compound, and you'll see a solid after that chemical reaction. With these reactions, we start with two ionic solutions as our reactants. Our products will be one ionic solution and one ionic solid. So with our letter equation, you start with AB and CD. Our products will be AD and CB. Just have a switch there between the B and the D. We've got an example reaction here, starting out with potassium chromate and silver nitrate. So potassium chromate, K2CrO4, and silver nitrate, AgNO3. They react together, will form one precipitate, so a solid, and the other compound will stay dissolved in water. This particular reaction will end up with silver chromate as our precipitate, and we'll have a solution of potassium nitrate. So it's kind of a cool reaction to see. We've got our potassium chromate is that kind of yellow dropper up top. When it reacts with the silver nitrate in the bottom of that test tube, you end up with solid silver chromate forming. So that's that red stuff that we see in the solution. Again, we've got another example of a double replacement reaction. I'll let you kind of take a look at that. We've got one more formula. It's not in your notes. We'll just kind of walk through what this reaction will look like. So we have iron 3 chloride and a calcium hydroxide. So 2 ionic compounds. So what will this produce? So we've got our 2 different ionic compounds. So the metals will probably switch places. So the iron will take the place of calcium. Calcium will take the place of iron. So we've got our iron and our calcium switching. So we'll end up with an iron hydroxide and a calcium chloride. Again, these are still ionic compounds, so we will have to balance out our ratios and our formulas. One other thing to keep in mind is that we've got a multivalent metal in this particular example. So iron can form a charge of 2+ or 3+. When we're dealing with these double replacement reactions, it does not change its valence state. So if it starts as a iron 3+, it will end as an iron 3+. So since our iron's starting as 3+, it's ending as a 3+. We're going to have to balance out 3+ with our hydroxide. Again, we can go through, go back, balance our formulas, try and figure out what each formula will be. We'll end up with an iron hydroxide and a calcium chloride. 2 metals have just switched spots. Then afterwards, our last step will be to balance the reaction. I will let you try to balance this. It should be pretty straightforward by this point. Questions about that, you can let me know. And just again, I've got a few more practice problems for you. Let you take a few minutes and you can go over these. Right, so we're just going to quickly look at the last two types of chemical reactions. We've got a neutralization reaction, also known as an acid-base reaction, and we've got combustion reactions. So neutralization reactions occur when acids and bases react with each other. So acids are compounds that typically start with an H, have a hydrogen at the start of their formula. Bases are compounds that typically have hydroxide at the end of their formula. Some bases do have ammonium in there, kind of odd cases. We'll look more at that in Chem 11. These acids and bases react together. That hydrogen and that hydroxide will react together, form water, and it will also form a salt. So our acid plus a base react together, form salt and water. When we see salt, it's not always going to be table salt. Salt is kind of just can be classified as any ionic compound. So we've got an example reaction here with HX. HX has a hydrogen, that is our acid, and MOH. MOH has hydroxide, that is our base. They react together, form compound MX. MX is going to be a type of salt, and we'll have some water. It's got a couple of reactions to go through with this. Got sulfuric acid, can neutralize calcium hydroxide. Again, just like a double replacement, hydrogen is switching places with the calcium to leave us with an HOH and some CaSO4. Can look at another type of a neutralization reaction with phosphoric acid and iron 3 hydroxide. So again, we've got the phosphoric acid, H3PO4, reacting with an iron 2 hydroxide. hydrogen and iron are switching places, and we're leaving with an iron 3 phosphate and some water. In this case, our iron 3 phosphate is a salt and water is water. So neutralizations are just special cases of double replacement reactions where we get salt and water forming rather than an ionic solid and an ionic solution. So take note of all of this reaction type is going to be very related to the lab project you're working on with your partner. So many of you have noticed by now you're dealing with some acids, also dealing with some bases. So some of you are kind of looking at these reactions, try and figure out what you can react together to potentially neutralize your solutions and what might you observe. It's got a few practice problems where we're neutralizing some acids and bases. Again, I'll let you try and go through these.